AI agents are computational entities designed to perceive their environment, reason about it, and act upon it to achieve specific goals. They stand apart from traditional software programs due to their capacity for learning and adaptation, granting them greater flexibility and intelligence. Perception, the first key aspect, is how the agent gathers information about its surroundings. This can involve diverse methods, tailored to the agent's embodiment and operational environment. For a software agent, this might involve receiving data from a database, a network, or user input. A physical agent, like a robot, might use sensors such as cameras, microphones, or touch sensors. The critical point is that the agent receives structured or unstructured data representing the current state of its world. Reasoning is the thinking part, where the agent processes the perceived information to make decisions. This can involve several techniques. Rule-based systems have the agent follow a set of predefined rules, which is simpler but less flexible. Machine learning allows the agent to learn patterns from data, enabling adaptation and handling of more complex situations. Different machine learning types can be employed, such as supervised learning, unsupervised learning, or reinforcement learning. Planning involves the agent creating a sequence of actions to achieve a goal, important for complex multi-step tasks. Knowledge representation allows the agent to store and use knowledge about the world for better decisions, potentially involving ontologies or semantic networks. Action follows the reasoning process. Based on its reasoning, the agent takes action that affects its environment. For a software agent, this might involve displaying information, sending a message, or manipulating data. For a robot, it could involve moving limbs, grasping an object, or navigating a space. The actions are aimed at achieving the agent's predefined goals. Learning and adaptation are key characteristics. AI agents learn and improve over time, often using machine learning to analyze past experiences and adjust their decision-making. This allows them to adapt to changing environments and improve performance. For example, a chatbot might learn to better understand user queries, or a robot might learn to navigate a new environment more efficiently. Autonomy is another defining trait. AI agents operate with some degree of independence. While initially programmed by humans, they can often make decisions and take actions without constant human intervention. The level of autonomy varies greatly depending on the agent's complexity and task. In conclusion, the diverse landscape of AI agents is best understood through their categorization and interaction with their environment. Reflex agents, the most basic, operate on predefined rules, while model-based agents leverage internal world models for decision-making. Goal-based agents strive to achieve specific objectives, and utility-based agents optimize a preference function. Learning agents, crucial for adaptability, evolve through experience. The environment itself plays a critical role, ranging from fully observable and deterministic to partially observable and stochastic. A fully observable environment provides complete information, whereas a partially observable one limits the agent's knowledge. Deterministic environments offer predictable outcomes, while stochastic ones introduce uncertainty. The interplay between agent type and environment significantly impacts agent design and effectiveness. Choosing the right agent architecture depends heavily on the specific task and environmental characteristics. Furthermore, the ongoing evolution of AI research continually yields new agent types and approaches. A deep understanding of these classifications and environmental factors is paramount for building robust and intelligent AI agents. This knowledge empowers developers to create agents capable of navigating complex and dynamic worlds, ultimately shaping the future of artificial intelligence. As the field progresses, the sophistication of agent design and environmental interaction will only continue to advance, pushing the boundaries of what AI can achieve. Therefore, continuous learning and adaptation within this dynamic field are essential for anyone seeking to contribute to the exciting world of AI agents.